All right, so today, young chemists, we're going to look at water and we're going to talk about concentration and, in particular, molarity, which is the measure of concentration that we're going to focus on. All right, so what's the point? By the end of this, you should be able to describe concentration of a solution, using the words molarity and understand what it is you're saying. You should be able to apply the formula. Molarity concentration is moles over volume. Okay, so this relates specifically to molarity. Um, and you should also be able to do it. So, where's my pen? You should also be able to do it using, here we go, these formulas as well. Okay, you should be able to use it not just on its own, but you should be able to go from, we have a certain mass of a particular substance dissolved into a certain volume of water. Therefore, what's our molarity? The last thing we want to be able to do is we want to be able to compare, just see why we use different measures of concentration. It's not the only one. Molarity is the one that makes the most sense for chemistry, but it's not the only one we have. And we want to look at where we would use them. So let's get into it. All right. So what is it? It's basically the amount of solute dissolved into a given amount of solution. Now remember, molarity or moles is just a number. It's just a count. It's like a dozen. We've talked about it before. You should know what moles are by now. If not, review those earlier videos. Okay, so moles, it's the number of moles of solute dissolved into a given amount of solution. Okay, so the amount of solute is the moles, the amount of solvent, that's the two things we're looking at. Often the most convenient measure of concentration is molarity. Now, if you're an environmentalist, or environmental scientist, you're going to be looking at things like parts per million, and these aren't done in molarity; they're done as a percentage of weight or a percentage of volume. All right, so the symbol is M. So 1 m, and that's the real shorthand way of doing it, is 1 mole of solute per litre of solvent, which we're now going to focus on writing it this way. Both work. This is the way we want you to do it. But we want you to recognize this. This should be the main way you do it, but you should recognize this as the same thing. Okay, this is a better way of writing it because it tells you exactly what it is. It's 1 mole per litre. This minus 1 means per, so another way to write that is 1 mole per litre. Okay, obviously it's like super neat and awesome, but you get the point. Now, how do we calculate it? The unit is the calculations right there. It's moles per litre. So molarity is the moles of solute divided by the volume of solution in litres. So the molarity of it. So C is the concentration, or the molarity. N is the moles. Remember, N for number. It's the moles, and V is the volume of solution. All right, so that's pretty straightforward. Let's do a couple of calculations. All right, so if we've got 0.2 moles of hydrogen chloride or hydrochloric acid, and it's dissolved into 1 litre of water, how do you do it? Well, there's your formula. So it's 0.2 moles divided by 1 litre, which gives us 0.2 moles per litre. Straightforward. Okay, so this square brackets, that's how you write concentration. So square brackets means concentration in this case. All right, so C equals N divided by V. Here we've got 0.01 moles of sodium hydroxide. It's dissolved in 250 mils of water. Only one conversion you have to make there, and then convert that into litres. Not so hard. So it's 0.01 divided by 0.25. It's a quarter of a litre straight away. That gives us 0.04 moles per litre. Really simple. Really, really simple. All right. So there are other ways to do it. Now we have percentage by volume, which percent volume by volume. So volume expressed as a percentage of the total volume of the solution. Now we use this when we're labeling medicines, foods, but it's liquid solutes Okay, so a liquid solute into a liquid solvent. We've got percentage by mass, which is percent W by W. Okay, so the mass of the solute is expressed as a total percentage of the mass of the solution. Now, this is a really good way of doing solid solutes. Okay, so it's helpful to remember that 1 milliliter of water is 1 gram of water. So it actually works quite easily if water is the solvent. So grams at a volume, so grams per liter, also makes sense. So grams of solute per liter of solution. Okay, again, this is where we tend to see this in commercial ways, and this, when I say commercial, I mean things that a non-specialist will buy off the shelf, and that makes sense because okay, this one here can be trickier for people to work out. You know, you see that, what does it mean? Not you, because you're a chemist, but the general public might, that can be trickier. As can these ones down here. Like, what does that actually mean? Whereas the general population, everyone knows what a gram is, everyone knows what a litre is. Hopefully they know what this means, but it will actually be usually written grams per litre, like that. Everyone knows what that means. So that's one that's similar to this. It's very similar to this, actually. And it's also similar to molarity, but it's really useful for just everyday uses. So, like non-specialist uses. So, parts per million by volume. All right, so volume in milliliters per kiloliter of solution. Now, again, we've used milliliters and kiloliters, so this is really good for liquid things. Now, sorry, liquid solutes and liquid solvents. Now, we use this in environmental studies. The other state of matter we measure as a liter is also gases. So it also works for air pollution, for water pollution, etc. So when they measure the mercury in, say, Minamata Bay, that's measured in parts per million by volume. Now, parts per million by mass is milligrams per kilogram of solution. Okay, so kilogram, milligram, put them in. There we go. So, environmental studies such as water pollution, when we're talking about solids that have been put into the water. All right, so when mercury goes into water, it goes in as mercury chloride, which is, a solution that's washed in there. But if we're talking about, I don't know, something else that goes in water, lead particles, etc., then we're talking about in parts per million by mass. Now, again, it gets confusing here because we go mass, weight, but you get the point. You know what it is. All right, so that's it. So they're the other ones that we use aside from molarity. As chemists, that's your bread and butter. That's the one you're used to, and yeah, cool, sweet. See you in the next one.